All right, so tell us how you heat all this big stuff up.
Sure. So one of the things you'll find if you have the chance to get any power hammer, if you go from no power hammer to a power hammer, you will find that you can do your work a lot faster. And it's if you're trying to accomplish a lot in a short period of time, if you're a hobbyist and you have limited time in the evenings or on the weekends, you're going to find that you will get more done if you can keep more metal hot. And that's what I found. I went from having a gas forge that was relatively small, and it would certainly heat what I wanted to heat, but then I spent a lot of time not doing anything while I was waiting for that metal to get hot again. So when I got power hammers and got bigger power hammers, I found that I wanted a bigger heating source so I could keep more metal hot longer. So I've constructed here just a simple box type of furnace. This one's about 18 inches wide and 24 inches deep on the inside and about 9 inches tall. It's just welded up out of steel plate and lined with kale wool, the same type of fiber-based insulation that most blacksmiths use. Because it's a rectangular design instead of a cylinder, the walls are not self-supporting. When you have the cylindrical forges, you can just roll up a blanket, slide it in, and once you've fired it once or twice, the fiber gets a little bit stiff and it just holds its position. In a rectangular system, that's not going to work. So what I did was I took the plate and welded boxes that are about 4 inches deep, and then I took the kale wool and I folded it like this to create, and I went back and forth, and then I ran steel bars through it to pin it in place, and then that's inset into the boxes. And so I have the walls and the ceiling are about 4 inches thick, and then the floor is a layer of soft refractory brick, fire brick, what we would call insulating fire brick, and then on top of that is a layer of the more hard brick, but it's half the thickness of the layer underneath. So the floor is probably 5 inches or even a little bit thicker than that. But the advantage that gives you is if you want to put a lot of metal in there, you have a very durable floor. And you have, with the thick walls, if you have something long and you happen to poke it into the wall, you're not going to completely ruin your furnace lining. So it's built around durability. The trade-off is that floor, being as thick and massive as it is, it takes a long time to get hot. So you're not going to see the furnace reach its sort of maximum operating temperature or even its, say, set point temperature for maybe an hour. Whereas if you have a small gas furnace that doesn't have a hard refractory floor in it, you can get those up to temperature in a relatively short period of time, 10 or 15 minutes, and they're going to be at whatever your desired operating temperature is. So this is great if you're doing a lot of metal. The nice thing about this, and we'll do it later today, is we're going to put a bunch of big chunks of steel in here, and we can have them all in there at the same time if we want to. So I can have several hundred pounds of metal in here at once, and I can because I have big hammers, I can take advantage of all of that hot metal. And so if you're running a production type of setup, this is really helpful, and you have very limited time where you're not actually performing forging activities. It's not only is it's homemade, this is a forced air furnace as opposed to a Venturi style furnace. So I have four burners on one side connected to a small electric blower that's set up with a rheostat so that I can control the RPMs on the blower. And then I have a 100-gallon propane tank outside the shop that's piped directly into this. There's a regulator on that tank. And I run, if I'm running steel, I'll run that around 10 to 12 PSI. If I'm running copper-based materials, I typically run that at about 8 PSI. I'm sure every furnace would be different, and each blacksmith would have to kind of figure out the settings for their own circumstances to match the material they want to forge. One of the things that I will say about a gas forge, and in particular this gas forge, is that this tends to create a lot of oxidation on work. I've seen other forges where the oxide layers are a lot less. I'm sure that has to do with tuning the mix between gas and air, and I probably could adjust that here, but most of the work I do is the Mokame I mentioned earlier, and I'm very comfortable with the settings I have for that, so I don't really mess around with it since I do steel on a less frequent basis, and when I am doing steel, I'm not really concerned about oxidation. If I was doing a lot of ornamental ironwork where I needed a nice clean finish, I would take the time to tune this to meet that need.